Hey guys, Mr. Riz here. I'm going to help you out with the 2.4 notes. So this is day one in calculus of the chain rule. So this will be another rule that we're going to learn how to use, just like the product rule and the quotient rule. And we'll just have to know like when it happens, how do we do it, and then what do we do with it. All right, so we're going to make sure today we can find the derivative of a composite function using the chain rule. Later on, we'll look at finding derivatives of function using just the general power rule, which we've done before. So, finding times that we can just get away with it, and then basically going through and simplifying the derivative of a function using algebra. So we'll try to make it look a little bit neater at the end. And then later on, we'll add some trig functions. So let's first talk about what the chain rule is. So we've yet to discuss one of the probably most powerful differentiation rules. Well, that kind of weird, but and that is the chain rule. So this is going to be an extremely useful tool to use to find the derivative because we won't have to use the product rule or quotient rule as much. All right, this rule deals with composite functions and adds a surprising versatility to the rules we discussed in the previous two sections. All right, so for example, if we look at the functions below here and we look at this list, on the left side is ones that we can use, we don't have to use the chain rule. On the right side are ones that we do. So if we just have x squared plus 1, we just do the normal derivative. But if we have the square root of x squared plus 1, you can see we have a function inside of another one. Or sine of x, totally normal, but sine of 6x, okay, we'll have to use the chain rule for. So you see, anytime we have a function inside of the other function, we're going to go ahead and use the chain rule. So the basic rule of the chain rule states that if y changes dy over du times as fast as u, and u changes du over dx times as fast as x, then y changes dy over du times du over dx, and that's as fast times as x. Okay, so this is pretty complicated. What mostly you guys will see is if we have the derivative of f of g of x. All right, so if you think of it, f is the outside function and g of x is the inside function. What we get is f prime of g of x times g prime of x. So we're going to take the derivative of the outside, leave the inside part alone, then times it by the derivative of the inside. All right, and so chain rule is one of those rules that it looks really confusing at the beginning, especially when we start talking about all these u's and stuff. But eventually we'll kind of get familiar with what the u means, especially when we start working backwards. But right now I want you guys to know this one down here. F of g of x, the derivative of that is f prime of g of x times g prime of x. So what we want to do here first is let's make sure you guys can identify what the inside function is and what is the outside function. So then we'll take the derivative. So let's go through, let me get my drawing tools out here. All right, so if we have y equals 4x minus 1 cubed, we technically don't have to do the chain rule here. We could write this all out, we could FOIL it, multiply it a bunch of times, distribute, and then do the power rule. That's something we could do, but this is going to be a whole lot easier to do in the end. First thing we want to do is, this is the inside function. What is the inside function? So we could say like u equals, the inside function is 4x minus 1. And then right here is the f of u, which there's a joke later on and we can talk about it, but the f of u, what's happening to this function here? This function is u cubed. All right, this 4x minus 1 is being cubed. Okay, so if we think about this, if we want to find the derivative here, if we want to find y prime, what we're going to do is the outside function is something cubed. The derivative of something cubed is 3 of that something squared. So what we do is we take the derivative of the outside, and then inside we leave the inside function alone. Now the only thing we have to do next is to then multiply by the derivative of the inside, okay, because we can't just leave it completely alone. It does reflect part of the derivative. The derivative of the 4x minus 1 is just 4. Then we're going to work on simplifying. So the only thing we can do to simplify here is we can multiply the 3 times the 4. And so the derivative of 4x minus 1 cubed would be 12 of 4x minus 1 squared. Okay. So let's keep working on these problems here. The next one. Let's look at the inside part. What is the inside function? The inside function here would be x squared minus 1. And what's going on with this x squared minus 1? Well, one, it's being multiplied by 4 and taken to the half power. So really, we have x squared minus 1 inside of the 4 of something to the half power. Okay. So let's start going through the derivative here, y prime. If we have 4 of something to the half power, okay, so if we multiply that, it would be 2 of that something to the negative half power. That something is the x squared minus 1. Now what we need to do is multiply that by the derivative of the inside. What's the derivative of x squared minus 1? That would be 2x. Okay, so if we want to simplify this expression here, we can multiply the 2 times the 2x and get a 4x. And then if we want to rewrite this here, the negative 1/2 power would put it on the denominator and inside a radical. And so we get an x squared minus 1. So the derivative of 4 radical x squared minus 1 would be 4x over radical x minus 1. Okay, let's keep this going. A couple more to do today. All right, sine of 3x minus 4. Okay, so what's the inside function? The inside function is the 3x minus 4. And what's going on with that? That u function, it's just really this sine of u. Okay, so if we're going to take the derivative of this, sine of any function, the derivative of that, sine of something is cosine of something. And that something is our 3x minus 4. What we need to do is just multiply by the derivative of the inside. The derivative of 3x minus 4 is 3. All right, and so we would go ahead and all we can do is really just multiply the 1 that's outside of the cosine with the 3, and our answer would be 3 cosine of 3x minus 4. Not too bad. All right, now one thing about the chain rule that's nice is if you don't really like using some of the rules before, like quotient rule here, you technically don't need to. So we could do low D high, high D low on this problem here and get an answer that would work. The other thing we could do here is we could try to work this around. What if we say that the inside function is x plus 2, and this function is really u to the negative first power, because all it is just on the bottom. So if we want to go ahead, we can go ahead and not use the quotient rule, and we can just go ahead and use the chain rule. So what is the derivative of something to the negative first power? Well, that would be negative 1 of that something to the negative second power. That something here is x plus 2. We're going to times that by the derivative of x plus 2. What is that? Well, that would just be 1. So if we were going to simplify this answer here, all right, we just multiply the 1 times the negative 1, which is negative 1. And then we could take this x plus 2 and put it on the bottom squared. And there's our answer. We would have got the exact same thing if we did low D high, high D low over low low, and simplified and all that. But this came out to be the same answer and got a whole lot quicker. So now let's take a look at the CYU that you guys will be working on the worksheet A. Let's look through it, see if there's any problems that would cause any confusion. Okay, so most of these problems here you look to see, okay, we got something 5 of something to the 4th power, something to the 2/3 power, something to the 1/2 power, something longer to the 1/2 power, something to the 1/3 power. So far all of these here shouldn't be too bad. The only time where it gets a little tricky here would be these trig functions. So one thing we haven't done is what if we have the chain rule inside of the chain rule? So what if we have 5 cosine squared? All right, so let's think about it. Our inside function is really like pi t, and that function is inside of the cosine of u, and that's actually inside of 5, x squared or something like that. So we have a function inside a function. So the biggest one we want to look at is like, okay, what's the derivative of 5 of something squared? So 5 of something squared would be 10 of that something to the first power. All right, now that something would be our cosine of something, and that something is pi t. Okay, so now we're going to times the derivative of the cosine of something. The derivative of cosine something is negative sine of that something. And then we got to times by the derivative of the inside. Derivative of pi of something is just pi. All right, so when we have the chain rule, we can have the chain rule inside of the chain rule inside of the chain rule. It can keep going on and on. We have so many links. We just keep unraveling. It's like unwrapping presents, right behind me. We just keep opening and opening until we get to the gift that we want. So all we got to do now is simplify this here, and it just takes some time. Let's see. We have a 10, a -1, and a pi. So our answer should be like negative 10 pi cosine of pi t times sine of pi t. There we go. So if you think about it here on this problem here, we could have like the inside is 8 theta, and that's inside of the cosine of u, and that's inside of u squared. So, okay, you'll do something, do the derivative of the u squared times the derivative of cosine u times the derivative, and just keep working your way like that, unraveling. Okay, if you guys have any questions, reach out and ask, but if not, have a great day, and I will see you guys next time for day 2.